11.1 3D coordinate geometry and spheres. Three-dimensional coordinate system will generally sketch it like this. X goes off in this direction and Y in this direction. That forms a horizontal plane, Z in the upward direction. This gives us a right-handed coordinate system. If you let your fingers go from X to Y, your thumb points in the Z direction. And we'll stay consistent with a right-handed coordinate system so that all our vector conventions work out. Consider the point 2, 3, 4. You can sketch that by first sketching 2, 3, 0 in the xy plane. You have to go over 2, over 3. We end up with a parallelogram. There's the point 2, 3, 0. Anything in the xy plane has a z coordinate of 0. And then we have to go up 4 units. You can use your fingers. That makes another parallelogram. That takes care of the perspective. And we end up at the point 2, 3, 4. Now if we want the distance from the origin to 2, 3, 4, this makes a right triangle. This vertical distance is 4. This horizontal distance, that's a two-dimensional Pythagorean theorem, square root of 2 squared plus 3 squared. And then d squared is equal to that squared plus that squared, which gives us this relationship. And then you can take the square root of both sides, and we have this. It's a three-dimensional Pythagorean theorem. It doesn't take a whole lot of imagination to imagine that if that's x, y, z, this is square root x squared plus y squared plus z squared. And the distance between 2 points, P0 and P1, is square root of x1 minus x0 squared, same for y, same for z. It's a three-dimensional distance formula. From there, we can generate the equation of the sphere. If you have a center x0, y0, z0, radius r, looks a lot like the circle equation from high school. You can simply square all three of these terms, set it equal to r, gives you the equation of a sphere. You can just sketch a very quick sphere. There's the center, and that would be x0, y0, z0, and some point, some general point, x, y, z. The radius is r. All you have to do is apply the distance formula to those 2 points, call r equals d, and you end up having this right here, the sphere equation. Three simple planes. We'll talk about plane equations in general, but three simple planes. X equals c is parallel to the yz plane. So for instance, x equals 2 would be a plane that would intersect the x-axis at 2, and it would be parallel to the yz plane. It would stick out from the board. Y equals c parallel to the xz plane, like y equals 2 would go this way. We'll eventually sketch some of these planes. Z equals c is parallel to the xy plane, and that would be like constant elevation. It would be up 2 units from this xy plane. Now let's consider a few problems. Suppose we want the equation of a sphere with center 2, 3, 5, and including the point 3, 4, 8. Well, the sphere equation, we can write that x minus x0 squared plus y minus y0 squared plus z minus z0 squared is r squared. This tells us that x0, y0, z0 is 2, 3, 5. So we can put those coordinates here, here, and here, and at least take us part way to the answer. And now it's just a matter of having the radius. Well, guess what? You can visualize these 2 points as being these 2 points. The radius, we just apply the distance formula. And r is going to be square root of, subtract the x coordinates, subtract the y coordinates, and subtract the z coordinates. and that's 1 squared, 1 squared, 3 squared, which is 9, so we get square root of 11. And we can substitute that in here and have our final answer. Square root of 11 squared, which is 11. And that is the final answer. Question number 2. Let's suppose we have x squared minus 2x plus y squared plus 6y plus z squared equals 5. And we want to know the center and radius. What we need to do is take that equation and put it in this form. And then we can, by inspection, tell what center and radius is. So we're going to have to complete the square. Let's start with x squared minus 2x. We have to do negative 2 divide by 2 and square it. Yeah, and then we can move on to y. We take 6, divide by 2 and square it, and erase our sphere. Okay, the z is already squared. There's no z term, so we don't have to complete the square. Okay, now we have to add these two terms to the other side. Negative 1 squared is 1, and 3 squared is 9. And so that's x squared minus 2x plus 1 plus y squared plus 6y plus 9 plus z squared equals 15. And now we can factor x minus 1 squared plus y plus 3 squared plus z squared equals 15. And the center is, you can just say C parentheses 1 comma negative 3 comma 0, and r equals square root of 15, a little bit less than 4. Okay, we'll be back shortly with the second sphere video. I'm going to erase this and set it up so I don't take up any more of your time.